Hello class, this is Advanced Math Lesson 5-6 on Monday 11/6/17. What I'd like you to do right now is to take out last night's homework, Friday night's homework, which is worksheet 5-5. Everyone should have this out on their desk as well as their notebooks. So take this out, take your notebooks out, and of course something to write with. I'll have Mr. Pazzi hit pause on the notes to give everyone a chance to take that out. Okay, we are going to go over a few homework questions. I've pre-picked the ones I want to go over with you. I'm going to start off with number 1. And number 1 is tan squared theta minus sine squared theta equals tan squared times sine theta times sine squared theta. And yes, I do realize that this worksheet was difficult, and as I said before, I intend to struggle on some of these. Okay, I am going to pick the left side just because I feel like there's more options and more things I can do. All right, now when I look at this, the first thing I think about is, oh, difference of two squares. And then as I've said before, I play it forward in my head and I think, if I were to factor this, would it help me at all? And if I were to factor using difference of two squares, I would get this, tan theta plus sine theta times tan theta minus sine theta. And to me, I look and there's nothing I can really manipulate here to get this to look like this. So I say never mind. All right, what are other options? Changing everything to sine and cosine. Sine squared theta over cosine squared theta minus sine squared theta over 1. Okay, well there's nothing I can do. I can't combine them yet because they're not common denominators. But I can multiply this second fraction, top and bottom, by cosine squared theta so that I can have a common denominator, so that I am able to write them as one fraction. Cosine squared at the bottom, sine squared stays sine squared. Take away the product of sine squared theta and cosine squared theta. All right, keeping an eye on what we're trying to get. Not quite there yet. This is all sine and cosine. This is tan and sine. But I'm hoping you recognize, what can we do up here? I'll give you guys a few seconds to think. Okay, I'm hoping you recognize that it's GCF. There's a GCF there of sine squared theta, which leaves you with 1 minus cosine squared theta over cosine squared theta. Okay, still not quite. Oh, well, I have the sine squared there that I'm wanting. Is there any way to get this piece here to tangent squared? I'm hoping here, this is screaming at you, change me. What can we change 1 minus cosine squared to? Sine squared theta times 1 minus cosine squared theta from your Pythagorean identities is sine squared theta. So I have sine squared times sine squared over cosine squared. Now I'm not going to multiply the sine squared times sine squared. I'm not going to make it sine to the 4th because I can see I have a sine squared here. So since this is multiplication, we've talked about ripping apart fractions before. When you rip apart fractions, it's different when you rip apart a multiplication fraction and an addition fraction. When it's multiplication, your denominator only goes under one of the fractions. It does not go under both. Do you agree if I were to multiply these two together, I'd get sine squared times sine squared in the numerator and cosine squared times 1, which is cosine squared, in the denominator. And I'm hoping you can see it here that sine squared over cosine squared is indeed tangent squared theta times sine squared theta, which is where we were, what we were trying to get. And don't forget, you box in not your answer, but saying that you are done with the problem. Tan squared theta times sine squared theta. Okay, next one I want to go over is number 3. Number 3 is sine beta minus cosecant beta quantity squared equals cotangent squared beta minus cosine squared beta. Again, I look at what are my options. Okay, I can do difference of two squareds here, but it's not going to help me with this. This side I can FOIL, and there's more things I can do once I FOIL, so I'm going to pick this side. And don't forget, you cannot distribute the exponent. You do have to write it twice and double distribution, in other words, FOIL. And don't forget, when you write it twice, it's the exact same sign twice. It's not plus minus. You're not doing difference of two squares. The base twice. All right, let's FOIL, and let's try to FOIL some of this in our head. We've talked about that before. Sine beta times sine beta is sine squared beta minus sine cosecant minus another sine cosecant is minus 2 sine beta cosecant beta, and a negative times a negative is positive cosecant squared beta. All right, I'm not going to work out every single one of these all the way through. I'm just going to get you part way through and at least set you up to move on, continue to move on, so you can finish them up on your own at home. All right, I'm going to continue. I'm going to write this. I'm going to leave it as sine squared beta for now. Takeaway, I'm hoping you recognize that sine beta times cosecant beta is 1, and 1 times 2 is 2, so minus 2 plus cosecant squared beta. And this is where I'm going to stop and let you finish. I will give you one hint. Pythagorean identity, sine squared is 1 minus cosine squared. You'll get your cosine squared in there. Cosecant squared is 1 plus cotangent squared. You'll get your cotangent squareds in there, and the plus 1 should maybe cancel out with this minus 2. So I'm going to let you try that on your own when you get home and finish it. Pythagorean identity, clean it up, and it should end up to this here. All right. I want to talk about number 5. I'm not going to do it with you, but I do want to talk about it right here. The hint is right side common denominator. Your common denominator would be 1 plus cosine, 1 minus cosine. So you'd multiply this one top and bottom by 1 minus cosine, and this one top and bottom by 1 plus cosine, and work it out. That'll be the hint I give you on that one. Okay, next one I'd like to do is number 6. Secant squared theta minus tangent squared theta all over tan theta plus secant theta equals cosine theta all over 1 plus sine theta. And same thing on this one. I'm not going to work it all the way through. I'm going to get you far enough where you can complete the rest on your own. I'm picking the left side only because it looks bigger and more to work with. And I'm looking and I'm thinking, what can be done? I can see at least right here that secant squared minus tangent squared is an identity. And I'm going to show it to you quickly. Secant squared secant squared minus tangent squared. Well, the identity, Pythagorean original identity, is tangent squared x plus 1 equals secant squared x. But when I subtract the tangent squared over to the other side, I get secant squared x minus tangent squared x equals 1. So this here is simply 1 over. Now again, I'm looking at what I'm trying to get, sine and cosine, so I'm going to change these to sine and cosine. Sine theta over cosine theta plus 1 over cosine theta. And oh look how nice, I have a common denominator. 1 over sine theta plus 1 all over cosine theta, which is as far as I'm going to take you, because I'm hoping from there you can see you're going to multiply by the reciprocal and you're pretty much done. All right, number 7, hint on number 7, FOIL and FOIL, double distribution. So write this one out twice, both of them with the minus, double distribution, otherwise FOIL. Write this one out twice, both of them with the plus sign in the middle, double distribution, in other words FOIL. Clean up, clean up, clean up, work it all out, and it does indeed come out to be 5. All right, next one I want to do is number 8. And I may leave off with this one. I may start the next one, we'll see. 1 minus secant beta minus cosine beta equals cosecant parentheses pi over 2 minus beta plus tan squared beta over secant beta. All right, we've talked, well, it's been a while since we've done these complementary cofunctions, but I've talked to you about it before. That's the side that should be like screaming at you, change me, change me. So when you change it to its complementary cofunction, the complement of pi over 2 minus beta is just beta. You drop the 90 minus beta piece. Cosecant, it has the co, so when you drop the co, it becomes just secant. So these are equivalent. Cosecant of pi over 2 minus beta is equivalent to secant of beta. And again, those were notes from our complementary cofunction lesson. It is here. Cosecant of pi over 2 minus x equals secant of x. It just replaced the x with beta. All right, so I'm just going to erase the parentheses. Secant beta plus tan squared beta all over secant beta. Now, I've talked to you before about splitting fractions with addition versus multiplication. How do I know to split this one? Because I can see that secant over secant is going to give me the 1. And I'm going to try to manipulate the rest of it to equal the second piece here. So secant beta over secant beta plus tan squared beta over 1 or tan squared beta over secant beta. Good. I'm hoping you said secant beta. Now, again, this is different from splitting a multiplication fraction. When you split a multiplication fraction like we did here, the denominator only goes under 1 because you're multiplying. When you're splitting an addition fraction, the denominator needs to go under both because you're adding and you need a common denominator when adding. If I were to add this fraction together, I would indeed end up with this up here. All right, this is going to give me my 1 plus, again, looking at what I'm trying to get, I have the 1 in place. I see secant, I see cosine. I don't see a tangent in there at all, so I'm definitely going to change the tangent and see what I can come up with. So I'm changing the tangent since there is no tangent in that problem. And again, when you look at your Pythagorean identities, tangent squared is secant squared x minus 1. Tangent squared equals secant squared x. It's actually down here in the rewrite section. Secant squared x minus 1. Secant squared beta minus 1 over secant is 1 over cosine beta. This is definitely a harder type of problem that you're going to see. All right, multiply by the reciprocal, 1 plus secant squared beta minus 1 times cosine beta over 1. I don't need that 1 in the denominator anymore. It's not necessary because there is no more fraction. So I'm just going to erase it. I'm going to leave you here. You distribute, and clean it up. Once you clean it up, you should indeed end up with this here. Okay, I would like to move on so that we can have time for our lesson. I did want to go over numbers 9 and 10, so we may save those for another day. So for now, do the best you can, get the rest of it done, front and back. And again, I'll try to go over 9 and 10 with you another day if needed. All right, you should put that aside and take out your notebooks. Okay, this is 5, 6. Solving trig equations. Today's date is the 6th. All right, 5, 6, solving trig equations. All right, I'm going to write this down first. Solve, find all values of x. Solve, find all values of x. Okay. Oh, and I do want to put this next piece here such that 0 degrees is less than or equal to x, which is less than 360 degrees. All right, it's been a while. This was back in Unit 3 that we did these in this restriction. Remember, it equals 0, but it does not equal 360. So if you're on the 0 line and you give me 360 as the answer, it's wrong because it cannot equal 360. You have to put the 0 because 0 and 360 are coterminal angles. All right, just a quick jump back to Math 3. You would have seen this an interval notation like this, 0, 360. Do any of you remember that? Bracket on the 0 because the 0 is included, parentheses on the 360 because the 360 is not. Or it would be written like this, 0, 2 pi. Bracket on the 0 because the 0 is included, parentheses on the 2 pi or the 360 because it is not. Your book writes it like this, so I just want to review and remind you what that means when you see it. It's the same as writing it this way. All right, we're taking a jump back to Unit 3. Sine of x equals negative root 3 over 2. Now, notice there's no inverse or arc notation here, which means we are not restricted to the right half or the top half. We're dealing with all four quadrants. So if I'm dealing with all four quadrants, all students take calculus, and sign is negative. Does everyone see that we're dealing with the bottom two quadrants? All right, what is your reference angle? Ignoring the negative, sine of what angle is √3/2? I'm hoping you said 60 degrees. You either use your hand trick or you use your unit circle. 60 degrees is here, and these are the y's, √3/2. All right, if you want to put pi/3, that's up to you. I will tell you right now, the book writes it this way, and the book answers in the back are written in radians. If you want to write them degrees, I do not care. If you want to write them as radians to match the book, that is totally up to you. All right, so when is sine negative in these two quadrants? So what is 60 in quadrant 3, and what is 60 in quadrant 4? And I'm hoping everybody agrees it's 240 degrees and 300 degrees. Okay, number 2. And before I go further, remember we're no longer dealing with the inverse or arc sign, so we're no longer restricted to the right half or the top half. We're dealing again with all four quadrants. All right, next one, cosecant x equals -2. I want to spend some time with this one because I have a lot of kids on the test messing this up. You are supposed to take the reciprocal of both sides, but when they take the reciprocal, they're not sure in how and what to flip. You never flip this. It's not 1/x. That's going to stay x. What's the reciprocal of cosecant x? Sine x. What's the reciprocal of -2? -1/2. So think of it as taking the reciprocal of both sides. What's the reciprocal of cosecant? Sine. What's the reciprocal of -2? -1/2. All right. So you're thinking, what is our reference angle? Sine of what angle? Ignore the negative. Sine of what angle is 1/2? Sine is the right side, so that's 30 degrees. And again, we're dealing with all four quadrants. And since it's negative, you're looking for 30 degrees in quadrant 3 and quadrant 4. So I'm hoping you came up with 210 and 330. Okay, I'm going to move right along. Number 3, √2 sine x plus 1 equals 0. √2 sine x plus 1 equals 0. All right, we're going to solve just like we would any other equation. I'm trying to isolate not just the x, but I'm trying to isolate the sine x by itself. So I'm going to subtract the 1. That gives me √2 sine x equals -1. The next thing I would do to get sine x by itself is divide by the √2. And I'm hoping you can see that sine of x equals -1/√2. And again, you're thinking of, what's my reference angle? I'm hoping everyone agrees that it is 45, ignoring the negative. Sine of 45 is 1/√2. Back to the all students take calculus, just like the last two. Sine is still negative, so it's the bottom. So what is 45 in quadrant 3? And what is 45 in quadrant 4? Give you guys a few seconds to think and write your answers down. Okay, I'm hoping we all came up with 120. Nope, I lied, I apologize. 225 and 315. Okay, number 4, secant x plus 2 equals 0. All right, just like we would in any other equation, we're going to subtract the 2, which means that secant x equals -2. Now, secant, we don't have our unit circle set up for secant. It's sine, cosine, tangent. So I'm going to reciprocal both sides. Reciprocal of secant is cosine, and the reciprocal of -2 is -1/2. Again, think of it as secant, the reciprocal of secant is cosine, the reciprocal of -2 is -1/2. All right, you're thinking, cosine of what angle is 1/2? Ignore the negative. 60 degrees. Here's the 60, you bring it down, cosine's the left side, cosine, this side is the sine. 1/2, again that, or use your unit circle. Cosine is negative in quadrant 2 and quadrant 3. So what is 60 degrees in those two quadrants? 120 degrees and 240 degrees. Or if you want to, I haven't been doing it on the others, but I could have, should have. You could write as radians, 2 pi over 3 and 4 pi over 3. You choose which one you want to write your answers on homework. Which way? All right. Number 5. Three tan squared x minus 1 equals 0. All right, I'm hoping we have the hang of it by now, that we can speed it up just a little bit. Add it to the other side, the 1 to the other side. Divide both sides by 3. That gives you tan squared equals 1/3. And there is an x in there that I just forgot to write down. Tan squared x equals 1/3. And I'm hoping you know when you want to undo the square that you square root both sides. The square root of tangent squared is tangent x equals, and remember when you square root both sides of an equation, it's plus or minus. Square root of 1 is 1 over square root of root 3 is root 3. So you have plus or minus 1 over root 3. Tangent is y over x, and if you're here at the 30-degree mark, y over x would be your 1 over root 3. Do you see that? Or again, use your unit circle. So I'm hoping you see that your reference angle is 30 degrees. Now, what quadrants would you be in if it's plus or minus root 3? Think about that for a second. I'm looking for the places where tangent's positive 1 over root 3 and negative 1 over root 3. And I'm hoping you've come up with all 4 quadrants. Do you see that? All students take calculus. It's positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4, so therefore it's all 4 quadrants. So 30 degrees in quadrant 1, 150 degrees in quadrant 2. What is 30 degrees in quadrant 3? 210, good job. And what is 30 degrees in quadrant 4? Good job, 330 degrees. Okay, number 6. Again, I'm going to speed it up just a little bit since we have the hang of it. I want to solve, so I am going to subtract the 1 and divide the 2. And I did forget to write my x in there, so I'm adding it in there now. All right, that gives me sine squared x equals -1/2. And just like we did on number 5, we square root both sides to undo the squared. The square root of sine squared x is simply sine x. And can you take the square root of a negative? You cannot. It's not mathematically possible unless using imaginaries, which we are not using here in this lesson or this unit for that matter. No solution. No imaginary solution. So technically no real solution is what we should write there, but I'm going to leave it. All right, why was there no solution? Because you can't take the square root of a negative and get a real number. Number 7, 2 cosine x minus 3 equals 0. Add your 3 over to the other side and divide your 2. I'm hoping I can do that all in one step. Positive 3 divide by 2. I'm hoping I didn't confuse anybody. I added the 3, divided the 2. All right, is this a unit circle problem? Do we have any cosine x equals 3 over 2? We do not. So what do? We draw our picture or think about it. What is cosine in words? Adjacent over hypotenuse. Think about that. Is that mathematically possible to have your adjacent side being 3 and your hypotenuse side being 2? Why not? Okay, talk to your people in your group about why this is mathematically incorrect. I'll give you guys a few seconds to talk about why does it make sense to have an adjacent side being 3 and a hypotenuse side being 2. All right, attention back up front. I'm hoping you said because your hypotenuse should always be your longest side, so it makes no sense to have a hypotenuse of 2 and your adjacent side being larger. That's mathematically incorrect. It's not possible, so this is also no solution. For a different reason from number 6, this was no solution because you couldn't square root the negative. This is no solution because it's mathematically incorrect to have a adjacent side larger than a hypotenuse side. It's mathematically impossible to draw a right triangle that way. Another reason to think of it for you visual people is if I were to graph this cosine x, just regular old standard cosine x, I'm sorry, this one here. If I were to graph this one here, this has a vertical shift of down 3, 1, 2, -3, and an amp of 2, 1, 2, and 1, 2. 1, 2, 3, 4, 5. Can you see that if you shift down 3 and you have an amp of 2, you're going to oscillate between 1 and -5? Can you see that? I'm not going to draw my numbers in there because we know it's really not important. It's just getting a visual. So your cosine graph would look something like this. All right, it's going to oscillate between 1 and -5. So the question is, when does it equal 0? Is it ever going to equal 0 if the graph oscillates between 1 and -5 forever? It's going to do this forever. It's never going to hit the x-axis at 0. So another way to think of it as no solution, or why it is no solution. Okay, moving along. Number 8, secant x times cosecant x equals 2 cosecant x. So remember, we've talked about before, as tempting as it is to divide and cancel out an x, you never do that because you can end up losing answers. There are times where you can get away with it and dividing doesn't lose an answer, but it's not that case all the time. So don't ever try to do it and figure, oh, I can get away with it this time, because that is not the case every single time. So again, what I'm saying is it's tempting to say, oh, cosecant x, cross out, and solve. Now again, I will have some of you say, well, I did it that way and it worked. Okay, it worked on this one, but it does not work on all. So do not do that. That's not a good tool to use when you're solving equations. All right, so I'm going to get it equal to 0. Secant x cosecant x minus 2 cosecant x equals 0. Mathematically, what can I do here? Can you guys see there's a GCF? What is your GCF? Good. Cosecant x, parentheses, secant x minus, there is something left behind here, it's minus 2 equals 0. All right, this is cosecant x equals 0 and secant x minus 2 equals 0. This is zero product property. When you solve and you said equal to 0, left side equal to 0, right side equal to 0, all those, again, first 2 units of the semester were to get us ready for these problems. Zero product property. Equals 0, equals 0. Reciprocal of both sides. If cosecant's the reciprocal of sine, 0 over 1. When you reciprocal 0 over 1, it is 1 over 0, which is undefined. Is sine ever undefined? Think about that on your unit circle. Is there ever a time that sine is undefined? No, it never is undefined, so no solution for this first piece. All right, that's not the whole answer because I still have this one to solve. So I'm going to add the 2. And that gives me secant x equals 2. Reciprocal of both sides. Reciprocal of secant is cosine x. Reciprocal of 2 is 1/2. Now, is that something we can work out on the unit circle? When is cosine 1/2? 60 degrees. Cosine is the left side, 1/2. Or you're using your unit circle, or you have it memorized in your head. All right. Again, using the all students take calculus, cosine's positive in quadrants 1 and 4. So quickly, 60 is obviously one of the answers, because if you're ever in quadrant 1, your reference angle is your answer. So 60, and find it in quadrant 4 as well. Yes, it is 300. Now, when you write your answer on the test, I don't need the no solution part. This is not necessary. This is what I would be looking for. You don't need to put 60, 300, no solution. This is all I would need. When I check your work, I would see your no solution section, and again, this is all that's needed. And again, kids who say, well, I would have got the same answer if I had divided. Yes, it works in rare instances, but that is not the case every single time. So do not use that as a method of solving equations. All right, number 9. Sine squared x equals 3 cosine squared x. All right, I'm going to get it equal to 0 so I can try and solve. Minus 3 cosine squared x minus 3 cosine squared x. Sine squared x minus 3 cosine squared x equals 0. Now, this is a test question, by the way, that it comes up like this and we're stuck and okay, I can't factor, there's no GCF, it's definitely not difference of 2 squares, and even if it was, would I want to try it that way? So you really have to think, I'm going to change one, which one should I change? In this case, it does not matter. Because they're both squared, you could change the sine squared using 1 minus cosine squared, or you could change the cosine squared to 1 minus sine squared. You could use your Pythagorean identity for either one. I'll repeat that. This is equivalent to 1 minus cosine squared. And that is equivalent, oh, let me cover the 3. That is equivalent to 1 minus sine squared. Now, since it doesn't matter, I'm going to pick this one only because I don't want to have to worry about distributing a negative 3. But if you choose to, you can. Just remember to distribute the negative 3. 1 minus cosine squared x, and I said that twice, that's what it is, using your Pythagorean identity. Look them back up, they're in your notes. Minus 3 cosine squared x equals 0. Okay, I have like terms here and here. 1 minus 4 cosine squared x equals 0. I am going to subtract the 1, or you could add the 4 cosine squared x. It's up to you. Negative 4 cosine squared x equals negative 1. Do you see what you should divide by next? Divide by, good job, negative 4. Reduce. Cosine squared x equals negative is positive 1/4. Now if you had added the 4x squared and divide the 4, you wouldn't have to worry about the negatives, but it doesn't matter either way because they both cross out. Square root both sides, and we can square root a positive. Cosine x equals plus or minus the square root of 1/4 is 1/2. Is that a value on our unit circle? If so, what is your reference angle? Cosine of what angle is 1/2? I'm hoping everybody came up with 60 degrees. Now, which quadrants are we dealing with if it's plus or minus? Well, cosine's positive in quadrants 1 and 4, and it's negative in quadrants 2 and 3. So we're dealing with all 4 quadrants. So you're finding 60 degrees in quadrants 1, 2, 3, and 4. And quadrant 1 is obviously 60. Quadrant 2 it is 120. And quadrant 3 it is 240. And quadrant 4 it is 300. All right, that is it for this lesson. Tonight's assignment is on your assignment sheet. Make sure you get it done.